So very good morning one and all. We are learning the subject of network analysis, or you may say at the circuit theory. So we are learning today the steady state parallel RLC responses, because already we know very well in this chapter there is a two classification. One is a steady state response and other is nothing but transient response. So in that definitely the connection matters, whether we are connecting the in series or whether we are connecting in parallel. The circuitry, that is nothing but the RLC. Okay, and we are interested to find the response after connection, after applying the conditions of your the steady state as well as the transient. But at present we are learning the steady state response of your the parallel circuit. So here we will simplify the numerical number 1, which is on the basis of your the parallel RLC steady state. Note on all of you. The current in the resistive branch, the current in the resistive branch of a parallel RC circuit, of a parallel RC circuit, of a parallel RC circuit is given by IR is equals to, is given by IR is equals to 10 cos in bracket 1000 t minus 10 raised to the power 0 bracket close ampere. IR is equals to 10 cos 1000 t minus 10 raised to the power 0 bracket close ampere. What is the current in the capacitance? What is the current in the capacitance? Assume R is equals to 10 ohm and the C is equals to 10 microfarad, and C is equals to 10 microfarad. So what is given here? Few parameters are mentioned and they are expecting we need to calculate the current across the capacitance, current which is flowing through the capacitors, that is nothing but the IC. The current which is flowing through the capacitor is nothing but the IC, and the two components value is given, that is nothing but the 10 ohm and the what we can say 10 microfarad. So how we can start? First of all, before going to start the session, always start with the writing the conditions. That is nothing but this is a steady state response of your the parallel RLC circuit. So here the two components are connected, that is nothing but your the R and the C are connected parallelly. So you just mention there the steady state response of your the RC parallel connection, RC parallel circuit connection. Next line, VC is equals to VR. VC is equals to VR. It means that whenever the two the components are connected parallelly, that is the R and the C, the voltage drop across the capacitor and the voltage drop across the resistor will be the same. That is mentioned here the condition. Okay, VC is equals to VR is mentioned. Similarly, how we can start the session now? So whenever we are saying VC is equals to VR, definitely we should aware from the what is the voltage drop across this my resistor, what should be my voltage drop across the capacitor, then only I can compare these two values. So how I can start? We know very well as per the Ohm's law, V is equals to IR. V is equals to IR. So this voltage is nothing but across the resistor. So IR is nothing but the current which is flowing through across the through the resistor along with your the resistor value. So what is my register? Register is nothing but the 10. Again, the IR equation is given. That is nothing but the current which is flowing through the resistance is mentioned here. The 10 cos in bracket 1000 t minus of 10 raised to the power 0 bracket close of ampere. Okay. So see here, this 10 is of a register value. This 10 equation is nothing but the IR value. So in this way, you will get the 100 cos in bracket 1000 t minus 10 raised to the power 0 degree. So first, whatever you got the condition, whatever you applied the condition for the parallel RC circuit, this is the equation number 1 you can note down, or the A you can write. Secondly, whatever you are getting the voltage drop across the VR is nothing but the equation number 2 or the B. I hope you have understood. Now come towards the next, that is nothing but the capacitive current IC will be obviously lead to the voltage of VR. And how it is possible leading and the lagging? Already yesterday in the one of the case I have told you the current always lead in the capacitance, whereas the current lags in the inductors. So same thing we need to apply here. How they are leading and then lagging? with the help of the by the 90 degrees. So similar to here, we are interested to calculate the IC, but how I can get my IC? Just because of that VC also. So see here how I can get my IC, because once we got the VR, that is equivalent to your the VC. Already we mentioned the condition. Okay, so VC is equals to VR, already we mentioned in the A part. Now to calculate the IC, the current which is flowing through what we can say, the current which is flowing through the capacitors is nothing but the omega CV. What is my omega? 2 pi f. You can say, what is my C? That is a capacitor value. This is V is nothing but the voltage. Okay, in this way you can write that equation. Fine. So what is my omega? That is nothing but the 2 pi f, and this what we can say 10 micro is also mentioned here. Angular velocity, this is nothing but your the angular velocity. This is nothing but the angular frequency or the velocity. You can write here the 1000 directly. This is nothing but the omega t. How we got this omega? Omega we can get directly from this equation. That is nothing but omega t. So this is nothing but the 1000. What is the value of the capacitor? That is a 10 microfarad. So 10 into 10 raised to power minus 6. Micro is nothing but 10 raised to the power minus 6. Okay. What is my value of the voltage across that one? Already mentioned in the previous slide. That is nothing but the 100 we have calculated. Now come towards the same equation, that is nothing but the cos in bracket 1000 t plus 80 degree. How we got 80 degree? How we got 80 degree? Yes, anyone can tell how we got that 80 degree? Because the 10 is already, and this is what we can say the leading by the 90 degree, and the previous was the 10 degree. So this 90 minus of 10, you got that 80 degree ampere. So in this way, final answer you will get as the current which is flowing through the capacitor is nothing but 1 cos in bracket 1000 t plus 80 degree bracket close of ampere. So go for the second unit. Numerical number 2, which is related on parallel RLC response of a steady state. So what is that numerical? So as shown in figure, all of information as shown in figure, which represents a parallel RL circuit, as shown in figure, which represents the parallel RL circuit, as shown in figure, which represent the parallel RL circuit being energized by a sinusoidal AC voltage, being energized with a sinusoidal AC voltage of V is equals to 100 sine in bracket, V is equals to 100 sine in bracket 1000 t plus 36 degree, 1000 t plus 36 degree bracket close of volt, 100 sine 1000 t plus 36 degree volt. Obtain the instantaneous value of currents through the R and L. Current through the R and L. Hence, obtain the total current in terms of RMS value. Hence, obtain the total current in terms of the RMS value. So circuit is shown here. If you observe this circuit, you will be able to find two things are connected parallelly. One is nothing but the component R, one is nothing but the other component is nothing but the L. So R and L are connected parallelly along with your the source, that is nothing but the voltage. So if you observe this circuit, you will find L is directly given as a 10 millihenry, whereas your the R is given as a 10 ohm. If you find, you will also observe the direction of the current which is flowing through the source is nothing but the total current, whereas the current which is flowing across the register through the resistor is nothing but your the IR, whereas the current which is flowing through the inductor is nothing but the IL. So in this way, the total current I will be equals to IL plus IR. So in this numerical, the voltage equation is given, and we are interested to find out the value of the currents, that is nothing but the IR and the IL. We need to calculate the value of IR as well as the IL. Okay. How we can start? How we can start? With the help of the Ohm's law also. I is equals to V by R. I is equals to V by R. The current which is flowing through the resistor is IR. IR is equals to V by R. So what is my V? V is nothing but the Vm divided by R. What is my Vm which is given already? That is nothing but your the how they written here the sine. See here sine in bracket 1000 t plus 36 degree. Fine. So how I can write it? This one is the 10. This value of your register value is also the 10. So there, here you can take as a 100 divided by 10, that will be your the 10. Okay, you just take here at the place of Vm, just substitute the value of 100. So 100 divided by the value of R will be the 10. So 100 divided by 10 is nothing but the 10. Sign will be as it is, 1000 will be as it is, 1000 t plus 36 degree ampere. Okay, so if you want to write the same equation, if we want to convert, you can say in other angle, that is also possible. How we got this 54 degree? How we got? Is there anything is mentioned here? As the obtain the total current in terms of the RMS value. Okay, how we can get this one? Yes, how we can get this one? How you got this one? That is nothing but the 54 in the previous slide only, that is mentioned here the 54. That is nothing but again the leading and the lagging case. So 90 degree you can take here. So okay, 90 minus of this one 36, so you will get the 54 here. So in the next case also you can do. So what is the voltage current through the inductor? The I is equals to again the V by R. So instead of R here, the omega L will be there just because of the inductor. So IL is equals to Vm divided by omega L, sine of 1000 t plus 36 degree minus of 90 degree. See here the leading and the lagging cases. Okay, so here the current will be lag in the inductor. Current is lagging in the inductor. So that's why, what is my Vm? Vm is nothing but the 100. What is my omega L? That is nothing but again the 1000. What is the L? L is mentioned 10 millihenry. So you need to note on here the 10 millihenry. Okay, then the sine of 1000 t plus 36 minus of 90 degrees. So that you will get the minus 54 degrees. Okay, what you need to keep here the Vm. we, we need to keep the Vm is 100 and the omega is nothing but 1000. L is nothing but the 10 milli, that is nothing but 10 into 10 raised to power minus 3. Then the sign will be as it is, 1000 t will be as it is, and the 90 degree minus of here the 36 you will get as a 54 likewise. Okay, so how they are represent? See here the calculation, 100 divided by 1000 into 10, this we will get as a 10. So directly we are taking here the 10 cos of the conversion is there, the 10 cos of 1000 t minus of 144 degree. How we got this 144 degree? Just by taking what we can say the entire sheet, because IR plus IL is there, so that will be the 180 degree. So in this way, what you can do from the equation A and the B, from the equation A and the B, how you can compare for the register value, that is nothing but the current through the R is nothing but 10, you have already got that value, 10 angle of minus 54 degree, whereas IL is nothing but 10 angle of minus 144 degree. So net RMS current can be get, total current we know very well, I is equals to IR plus IL. So what is my 10 angle of minus 54 degree plus 10 angle of minus 144 degree? You can add, because already at the beginning only I have explained you how I can get my I. I will be the total current which is flowing through the entire circuitry, which will be the combination of the current through the R as well as the current through the capacitance. So by adding these two equations as okay, by adding these two equations, you can convert this polar form into the rectangular, convert this polar form into the rectangular with the help of the calci. You can take the magnitude of the 10, you can shift, you can press the from the polar to the rectangular, then the equals to, so you will get one of the value, then angle. In this way, you can get the you can convert this polar form into the rectangular, again this polar form into the rectangular, and you just convert this one. So finally, you will be able to find that answer is nothing but your this is the final equation, you can say, not the answer. It's very difficult to find out all these things, so you just keep it as it is. That is the current, net current or total current will be equals to, that is nothing but 10 cos 54 degree minus g of sine of 54 degree plus 10 cos likewise. Otherwise, even though you are going to stop here, then also you will get the marks, no need to worry. Up to this polar form also the answer will be correct, treated as correct. Okay, so in this way we have simplified the next numerical. Now we will go for the third numerical. See here, if you want to simplify, you can. Okay, the simplified equation is mentioned here: 5.88 minus j of 8.1 minus 8.1 minus of j of 5.88. So in this way, this 5.88 and the 8.1, you will get, okay, minus 2.22, and this is minus j 8.1 and minus j 5.88, that will be 13.97. That is in the imaginary. So this is the real, this is the 2.22. 2.22 is the real, and this 13.97 is the imaginary. So in this way, that is nothing but the ampere. And you can again, if you want to convert this rectangular form into the polar, that is also possible. And finally you will get as 14.14 angle of minus 90 degrees. So all of you pay attention here. Keep remember the steps of your the conversion from the polar to rectangular and the rectangular to polar. So it will be easy with the help of the calculator also. Okay. So finally you will get the I. Okay. Now for the third numerical, the applied voltage is the applied voltage in a parallel RLC circuit is given by. See here, in the first numerical we have solved on the RC circuit. In the second numerical we have solved on the RL circuit. Now the third is nothing but the R, L and C all are connected parallelly. So if the equation is given, V is equals to 50 sine in bracket 5000 t plus pi by 4 bracket close of V. If the values of R, L and C be given as a 20 ohm, 1.6 into 10 raised to power minus 3 Henry, and the 20 microfarad. Find the total current supplied by the source. See here, the equation is given, the value of the RLC is given, and what you need to find the total current which is applied to the circuitry. So in the parallel RLC circuit, the net current from the source will be the vector sum of the all the branch current, that is nothing but the IR, IL, IC. Okay, IR, IL and the IC. Okay, so how we can start? For getting the total current I, you need to calculate the IR, you need to calculate the IL, you need to calculate the IC. Once you got the IR, once you got the IL, once you got the IC, you can add all the three values and you will get the total current. So we will start one by one. Number one, we can start with the resistor, because R is connected parallelly, L is connected parallelly, and the C is, all these three components are connected parallelly. So with the help of the Ohm's law, I is equals to V by R, that is nothing but the IR is equals to V by R. So see here, what is my equation? V by R. So V is given here. Where is that? In the above, you may check the simultaneously, you may check, that is a 50 by root 2 angle of 45 degree. How I got that R? R is nothing but the 20 degree. So if you just multiply, okay, 50 divided by root 2, okay, 50 divided by root 2, you will get some value. Okay, and that value divided by 20, because at 20 you can take as here, at this place 20 angle of 0 degree. So numerator and denominator will divide, and the angle will be theta 1 minus theta 2. So here will be the 45 degree will be as it is. Okay, 1.768 angle of 45 degree ampere is the current which is flowing through the resistor. Getting? So in this way, this V you can get it. Next is nothing but the current which is flowing through the inductor. Current which is flowing through the inductor. I hope you have understood. V is equals to Vm by root 2. This case is nothing but V is equals to Vm by root 2. Okay, in this way we got that 50 were divided by root 2. Now come towards the next, that is nothing but the IL. I is equals to V by R. Instead of R, here will be inductor. Inductor is nothing but the XL. XL is nothing but the omega L. We remember I is equals to V by R. Instead of R, here will be the L, and L can be written in the inductive reactance, that is nothing but the XL, and the XL will be your omega L. Now substitute the value of this V will be again the Vm by root 2, that is the 50 by root 2, and this will be the angle will be as it is. That omega already we can get from this one, that is nothing but the 5000 omega L. L is given in the above numerical, in the numerical, that is 1.6 in millihenry. So here 1.6 into 10 is to power minus 3, and the angle will be here the 90 degrees. So now you just divide this one, get this one. So numerator and denominator will be division will be happen, and the angle will be 45 degree minus of 90 degrees. So 45 minus 90, again this minus 45 you will get, because theta 1 minus theta 2, whenever the polar in the numerator and the polar in the denominator, so definitely the magnitude will be divided first and the angle will be over the theta 1 minus theta 2. But whenever there is a multiplication, at that time theta 1 plus theta 2 will be the case, we remember. Now come to the point here. After this division, you will get 4.421 angle of minus 45 degree ampere. Okay, how we got this XL? XL is equal to J omega. J will be the imaginary. The omega is the 5000 from the above equation you can get. L is nothing but 1.6 into 10 to the power minus 3 ohm. Now the third part is nothing but the current which is flowing through the capacitor. Okay, the current which is flowing through the capacitor. How we can get the current flowing through the capacitor? That is nothing but my IC. That is nothing but my IC. So IC is equals to V by X. IC is equals to V by X. Here you can write here the XC also. You can write here the XC better way. You just write here the XC. I is equals to IC is equals to V divided by XC. Why we are taking here the XC? Just because of your the capacitive reactance. So how we can convert this in the voltage form? That is written here, because we are having the voltage equation. This is also one of the alternate form. So J into V omega C. J into V omega C by after converting this one. So here what is my V? V equation is already mentioned here. That is nothing but 50 by root 2. Okay, 50 by root 2, this entire term is converted here, 50 by root 2 angle of this 45 degree, angle of 45 degree into, this is the V, 50 divided by root 2 angle of 45 degrees, nothing but the V. Now second is omega. Omega is what? 5000 is the omega. What is the capacitor value? 20 microfarad. So this is 20 into micro is 10 to the power minus 6, and the depending upon the leading and the lagging, the angle will be 90 degree. Angle will be the 90 degree. So now 50 divided by root 2 will be one value, and that you can multiply with the 5000, multiply with the 220, multiply with the 10 raised to power minus 6. So you will get one of the answer, that is nothing but you are the 3.54. First do 50 divided by root 2, then multiply with the 5, multiply with the 20, multiply with the 10 raised to power minus 6. So you will get as a 3.54. Then the angle, these are the nothing but you are the angle. So angle 45 degree and the 90 degree you can add, that is nothing but 135 degree ampere. I hope this you have understood how to calculate the total current, which is equals to in the parallel circuit IR plus IL plus IC. IR plus IL plus IC will be equals to your total current. Will be equals to your the total current. Now come next. So what is the case now? What is the situation now? What you need to do here? So now the third part, which is the final part, we need to calculate the total amount of a current which is flowing, or you can say the net current flowing through from the source. Okay, flowing through the circuit from the source. So what is my I will be equals to IR. I will be equals to IR. I will be equal IR plus IL plus IC. IR plus IL plus IC. Now substitute the value of IR, 1.768 angle of 45 degree. Second, plus what is my IL? 4.421 angle of minus 45 degree. What is my third current? That is a 3.54 angle of 135 degree. So see here, in all the cases, what you can do is, you can convert this one. This is the one of the alternate form, that is nothing but by how to convert directly this polar form, this polar form, this polar form into the rectangular. This is the possibility to convert into the rectangular form. Just take the magnitude common outside. So cos of angle plus j of sin of angle, cos theta plus j sin theta. Keep remember to conversion for the polar to rectangular directly without calci. That is nothing but cos theta plus j sin theta, cos theta plus j sin theta. Just take the magnitude outside, because for we are multiplying with the both, that's why. So just take the magnitude, 1.768 will be outside, and the cos of theta is nothing but the cos of 45 degree plus j of sin of theta is nothing but again j sin of 45 degree will be for the first case, that is nothing but the IR. Similar to that, the magnitude will be 4.421, which is outside. In bracket again the cos theta minus j theta. Why this minus? Just because of this angle. So minus j of sine theta. So here the angle, here the sign is the minus, that's why minus sign. What is my angle? That is nothing but 45 is also here, 45 is here. Here is also 45, here is also 45. Now come towards the third, that is nothing but 3.54 is the magnitude. Just take outside that magnitude. Sine theta, okay, here is the plus. That's why sine theta plus j, cos theta plus a sine theta. So 3.54 will be outside. Cos of theta, theta is 135 degree plus j of sine of theta again 135 degree. Now come towards here, to just convert cos 45 will be whatever you are getting plus j sine 45 degree, you will get something. Again, the in this way you can calculate, you can multiply in all the cases, and you can find as final answer 1.873 plus j of 0.627. Final, after doing all these things, after multiplication, after what you can say, the addition and all, you will get final answer as 1.873 plus j of 0.627. So this is in the rectangular form. 1.873 plus j of 0.628 ampere is in the rectangular. Convert into the polar. 1.975 angle of 18.5 degree ampere, which is leading. Okay, which is leading. If you are getting the minus, it means that that is lagging. Okay, so in short, you can say the net current from the source of I is nothing but 1.975 angle of 18.5 degree ampere. I hope you have simplified this numerical. So in this way, today we have solved three numerical on the steady state parallel RLC responses. Okay. In the next lecture, we will continue the remaining numerical on the parallel RLC network. And later on, we will start the session on the transient response. Okay. How the RLC can be connected, whether the R is connected with the C, whether R is connected with L, whether RLC is connected, and the transient response with respect to the time period. What will be the effect of the switches when the switch is closed? What will happen to the entire circuitry when the switch is open? What will be the case? That all these things we can observe in the transient responses. Okay. So this was the first part related to the steady state sinusoidal AC RLC circuit series and the parallel circuit, you can say. And the in the next content is nothing but the transient response. So in this way, I'm going to stop here. Thank you so much.